Hello everyone, good morning. Am I audible to all of you? Can you please confirm in the chat? Okay, I think I'm audible, guys, to all of you, and welcome back with another session of our end-to-end self-driving car implementation series. So yesterday I already discussed about the project overview, like how we are going to implement this particular projects and all, and what are the tools and technology I'm going to use in this particular project. So everything I was discussing like yesterday. So today, what I will show you, I'll show you like how we can exactly collect the data for the trading, like with the help of that particular simulator software, how we will be collecting the data. That means the trading data. And whenever you are collecting the data, so what are the things actually you have to keep in your mind? I'll be discussing each and everything. Then once we collected the data, I will also show you how we can perform some basic pre-processing step, like how we can load this particular data, what are the columns are very like really required in this particular projects. I'll be discussing each and everything, right? But before that, let me show you where you will get this particular resources and all. Like yesterday also I created one GitHub repository, and there actually I'm going to update all the code. So if you want to get this particular link, so what you can do, you can come here in the community program. So here you will see my courses called end-to-end self-driving car implementation. Just let me, yeah, so this one, end-to-end self-driving car implementation. Now make sure you logged in with your account and you enroll for this particular courses. So I already enroll it. I'll just go to the dashboard. So if I go to the dashboard, guys, see, this is the first video. It is updated in the dashboard. With respect to that, the resources is also updated here. Okay. So what you can do, you can get everything from here only. And here we have already given some assignment and quizzes. Whatever things you are learning, just try to like attend this at the assignment and quizzes also, just to evaluate yourself, like whether you are learning that particular topic in a good way or not. Okay. Yeah. So now, guys, what I will show you, I think yesterday I was discussing about that particular software. That means the simulation tool. So let me just open this particular link. So this is the repo link. So Udacity Car Simulator. And I already told you how to download this particular simulator in your system. Okay, so there is a link they have already given. So you just need to download the version 1. And if you're using Linux, Mac, and Windows, so with respect to your configuration, you have to download this particular simulator. So I already downloaded this particular simulator in my system. So let me just open it quickly. So here is the simulator, guys. Now, if I just double click, so it will open up that particular simulator for me. But before that, you have to set some configuration, like what would be the screen resolution and all. You have to select that particular things. Now, see, this is the window. Now here I'll select the highest resolution and click on play. Now see, guys, this is my car simulator. Now here I was discussing about, here you are having two mode. One is like training mode and there is like autonomous mode. In the training mode, we'll be collecting the training data, and in the autonomous mode actually we'll be testing our model. The model actually will be training, right? And it is having two track. Either you can use this particular track to collect the training data, either you can use this particular track to collect the training data. But I'm going to go with the default one. That means the like first one. Now if I click on the training mode, you will see this kinds of interface. Now here you just need to manually drive this particular card. Okay, you just need to manually drive this particular car. But before driving this particular car, what you have to do, you have to record your video. So if you want to record your video, so how to do it? So there is a record button you can see. You just need to click on this particular record button. So let me click on the record button. Now it will ask for the location where it will save those are the image and data. So by default it will pick up this particular folder only. Now I'll just click on select. Now see, recording has started and it has created one log file. That means the CSV file. Another is like image folder. Now if I drive this particular car, it will automatically collect this particular image. See, now make sure whenever you are driving this particular car, you are driving in a good way. Just try to take a correct track. Otherwise, whenever you will be training the model, your model will go biased. Okay, so that means you have to drive perfectly, because here this is the behavior cloning actually we're doing, right? And you can see the speed and the angle actually it is automatically getting captured, because I already showed you it is having 3 cameras. Okay, with the help of 3 cameras it is capturing every images, and it is also having some sensors. With the help of sensors actually it is collecting that particular standing angle and the speed. So at least you have to drive this car 3 times in this particular track if you want to get a like very good data set. I'll also show you one alternative if you don't want to collect the dataset, where you can get this particular data. So there is a GitHub actually. One guy has already collected these are the data and he has published in his GitHub. Okay, I'll tell you how to download it. First of all, let me complete one track, then I can tell you what you have to do. Okay, I think one track is complete. Now what I will do, I will just turn around this particular card and I will go back again. Now you have to go this side so that your data won't be biased. Okay, because I uh, drove left side as well, right side as well. Okay, so both data would be same. So let's say you have completed your driving part. Now what I can do, I can stop this particular card and I can stop the recording as well. Okay, now if I go back, now you'll see all the image has been captured here. So see guys, all the image and it has collected 5,352 images. Okay, now see all the images and I already told you it is having three camera, center camera, left camera and right camera. So three images are present here. Three side images are present here. Okay, and with respect to that, it has also created another CSV file. In this particular CSV file, all of starting angle, then whenever let's say you are um, see, let me show you your image location. That means three image location, center, left and right, and with respect to the starting angle, okay, and the speed. Okay, starting angle and the speed, and there is another value it has captured. I will tell you whenever I load this particular data in my Jupyter notebook, that time I'll tell you, okay, what is this parameter. Yeah, so that's how actually I have to collect the data for all the like images. Okay, so now let me close it. Yeah, so this is the data. This is the data actually collecting part. Now what I have to do, I have to load this particular data. Okay, I have to load this particular data in my Jupyter notebook. So here you can use Jupyter notebook. Either you can work with Colab notebook. It's completely fine. But just to make it simple, I'll take Colab notebook because here I don't need to do so many setup. So I'll open up on Colab notebook here quickly. Yeah, so I'm going to name this as self-driving car demo. Okay, now here you can connect with the GPU. So change runtime type. I'll select this particular T4 GPU. Now let's connect this particular node. Now here you can check you got the GPU or not. So for this, you can execute this particular command NVIDIA -SMI. Okay, so here you can see I got Tesla T4 GPU. Now let me show you one beautiful repository. So this guy actually has collected all the data and he has published in his GitHub. So from his GitHub itself, I'll download this particular data. Let me show you. So see guys, this is the GitHub and this is the same folder structure as you can see, image and this particular CSV file. If I show you, so image and this particular CSV file. So he has updated in his GitHub. Now if I open this particular image folder, see all the image are there. Okay, so he has collected so many images. He has dropped this particular car at least 3 round in that particular track. Okay, and he has collected all the data for you. Okay, so let me just go back. Yeah, and this is the CSV file. Okay, that means the steering angle, the position of the car. Okay, everything is there. Okay, now what I have to do, I have to clone this particular data in my collab notebooks. Okay, so for this I can execute this particular command. So you just need to write git clone and give this particular URL here. Okay, so here's the command. So clone, and you just need to give this particular URL. Okay, so copy this particular URL and give it here. Okay, not this one. Yeah, this one, I think. This one. So copy this particular URL and give it here. Okay, now if I execute, you'll see it will automatically download the data for me. So it will take some time because there are so many images. Okay, done. Now if I refresh, see, this folder contains around 12,160 images. Okay, like it's like huge image. Now if I see inside track images, I'm having all the images. So, and this is the CSV file. This is a CSV file. So now I have to perform some pre-processing step. Okay, I'll tell you what are the pre-processing step are required. But before that, first of all, let me show you how we can load this particular data. So first of all, I just need to import some of the libraries. So let's import. First of all, I need operating system OS. Then I also need NumPy. So import NumPy as NP. Then I also need something called matplotlib. So I'll just import matplotlib. Okay, .pyplot as PLT. Then I also need something called MP image from matplotlib. So I'll just write import. Okay, matplotlib. Matplotlib.image as MP image. Okay, IMG. Yeah. Then I also need keras from the TensorFlow. So from TensorFlow, okay, import keras. Then I also need TensorFlow. So import TensorFlow. As TF. Then I also need something called sequential layer. Okay. So as of now, I'm not going to import these are the layers and all. Whenever I will define the model at that time, actually, I'll import these are the library. Let me see anything is required or not. I need some more library. So let me just import them also. So these are the libraries are required. So CV pandas, npath random. Then I also need something called shuffle, trend test split, and this particular library. Okay. Yeah, I think everything is fine. Now let me import them. Okay. Now what I'm going to do, I'm going to first of all set my data directory. As you can see, my data is present inside track folder. Okay, inside track folder, my data is present. So first of all, I'll just write a data directory. So data dir is equal to. So this is track. It should be track. This is track. Okay. Now, first of all, I have to assign some column name. As you can see, it is having some column, but the column name is not assigned. So first of all, I have to assign the correct column name here. So let me see. So this is the center image. The first one is the center image. And the second one is like, this is the left image. Then the right image. Okay. And the next one is this value. We call it as starting position. And this is throttle and this is reverse. Okay. And this is speed. Now let me mention all of them one by one. So what I will do, I'll close it. Just a minute. Mm, just a minute, guys. I think some issue is there. I can refresh this particular page. Okay, I think now it is fine. Now here I can mention the column. So the first column uh, is nothing but it's a center image. Okay, center image. Then the second column, it's left image, and the third column, it's right image. Okay. Then the next column is steering. Okay, steering. Then the next column is throttle. Okay. So what is throttle? I'll tell you. If you already know about cars, so I think you know what is throttle. So it's throttle. Okay, throttle. Then I have something called reverse. Okay, reverse. And there is another one called speed. Okay. Now let me show you this particular throttle. What is throttle in the car exactly? So throttle in car. Sorry, in car. Yeah. So the throttle system regulates the amount of air entering in the engine, indirectly controlling the fuel air mixture needed for the engine power. When you press your foot on the accelerator lightly, the throttle valve opens slightly and to left in a small amount of air. That means what happens actually whenever you are driving this particular car. Okay, so let me show you. Whenever you are driving this particular car, that means whenever you are pressing accelerate, that means the up arrow key, this is the accelerate. Okay, so the throttle is getting actually connected that time, and it is sending some air to the engine so that engine can get the power. So this is the value actually it is also capturing. Okay, so that's why I told you it is having some sensors. It is also capturing these are the data for you. Okay, so this is the throttle exactly. So that's why they're telling this is the throttle. Now apart from throttle, actually what you are having, center image, left image, right image. Steering means how much steering position you are moving. So this is the steering. As you can see left hand side, you can see the angle. Okay, this is the steering position. And apart from steering position, what you are having? If I show you, throttle I have already explained, reverse. That means whenever you are taking the cars in the reverse position, okay, reverse position, okay. So it is also capturing this reverse value. Okay. Now after reverse, what we are having? We are having the speed. So whenever we are driving this particular car, you can see right hand side speed is also showing. Okay, so this is the speed of the car. So that's how actually we are having. These are the value. These are the value in this particular CSV file. So I have to load this particular CSV file and I have to extract my data. So here I only need the starting position of my car. Okay, with respect to the image. Now let's say you are creating some advanced application. You are also considering the reverse position, speed of the car. Then uh, this one. When your car has to be like brake. So if you want to integrate these are the technology as well, so you can take these are the data as well. Okay, for the analysis, but I'm going to make this particular application as simple. So that is why I'm going to use this particular starting angle only, because yesterday I was already discussing about based on the environment, based on the road position, I'll be like making the decision how much starting angle I have to move. Okay, if I want to perfectly drive this particular car on this particular road. So this is the idea. Now what I will do, guys, I will just read this particular data first of all. So this is my column. So if you want to read the data, so first of all you have to use something called, I'll store this particular data in the data variable and I'll be using pandas. Okay, pd.read underscore CSV. Okay, because this is a CSV file, and inside this particular CSV file, you just need to give the location of the CSV file. If I see show you, so it is inside track. So here I can write os dot os dot path dot join. Okay, and I'm going to join with my data directory. The data directory I have prepared here, as you can see, track. Inside track, I'm having something called this particular file called driving log.csv. So here I can copy paste this particular file here. Okay, yeah. Then here I will also pass the column name. So name is equal to, okay, name is equal to column. Name is equal to column. Now I want to show everything. So I can set the limit. Okay, display like maximum column limit, because it will otherwise it will show like half of the data. I don't want that. I want to see everything. That's why I set this particular parameter. Now if I execute, okay, read CSV got an expected argument called name. Okay, why it's giving me the error? Okay, it should be names, I think. Okay, not a name. Value must be non-negative, integer, or none. Okay, so I got another error. Just a minute. Because pandas has updated so many things, so sometimes this error will come. You have to fix it. What is the error here? Header USB CSV file header is equal to -1 used to work internally when they didn't see the ratio value passing the negative invalidated. Perhaps the current value error, especially in none instead of none in case it is passed. Okay, so it is not taking -1. So what I can do, maybe I can comment out and I can execute again. Let's see. Yeah, now if I show you my data dot head, so this is the data, guys. Yeah, I think it is visible now. So this is the data. So now guys, you can see this is my center image location. This is my left image location. This is my right image location. And this is the steering angle. This is the total value. This is the reverse, and this is the speed of my car. Now here one issue you can see here. This particular location is my local system location, like inside C drive user. Okay. So he has like stored this particular data. So this is the like local disk location. But here is the data. Actually, you can see it is in collab. Okay, it is in collab. So I have to delete this particular location. Okay, I have to delete this particular location only. I have to keep this particular image name only. Only I have to keep the image name only. So how to do it? So for this, actually, what I can show you, I can write one function here. Okay, so let me write one function. So I'm going to name this function as def path leaf. Okay, path underscore leaf, path leaf, and here I'm going to pass the path. Now what it will do, here I'm going to apply something called this particular NT path. I think I have imported, you remember. So this is the library I imported here. Yeah, so this particular library I'll be using to split my path. Okay, so in NT path, and here I'm going to write split. Okay, split, and inside that I have to pass my path, and it will return you two things. One is like head path, and there is like tail path. Okay, so only I need the tail path. I don't need the head path. That means this is going to be your head path, and only the file name should be the tail path. But I only want my tail. Okay, tail, that means the file name. So I'll return. Okay, return the tail only. Okay, return the tail only. So once it's done, then I have to apply for all the columns. So for this, what I have to do, first of all, I'll call my data and to apply on the center image. First of all, center image. So I'm going to apply here. I have to call this particular apply function, and I have to call this particular function. That's it. Now I'll also do it for my left image, then also for the right image. So this is my left image and right image. So left, and this for right. Okay, so once it is done, I'll print my data again. So data dot head. Now if I hit enter, guys, so you will see my see, I simply pre-processed my path. Now you can see it is only the image name. It is only the image name. I already removed that particular path from my analysis. Okay, now easily I can load the data because it is inside track image, and this is the image name. Okay, So till here, guys, if you are having any kinds of query, you can ask me. If you are able to understand this particular code and all, because this is like a very simple code I'm writing. Okay. If you're already familiar with pandas and all, maybe you will be able to understand, okay, what I'm doing here. Great. Now what I will do, guys, the next thing, first of all, let's visualize my data. So here I already written one code, just a minute. Yeah, now if I execute, so basically I'm just plotting my staring, okay, staring angle, as you can see. So this is the staring angle I'm having. I already told you. So this is the staring angle I'm having. I'm just doing a distribution, okay. I'm just doing a this particular histogram on top of my staring column. Now here, if you see, this is normally distributed, but one issue you can see here, the zero value is more. Zero value is more in this particular data. Now, anybody tell me why zero value is more? Now, if I open this particular simulator and if I click on the training mode and if I drive the car, just check the angle. Just check the angle here. Just check the angle and try to decide. See, most of the time, whenever you are driving this particular car, you are driving in the middle position. Okay. And zero capturing a lot. Okay, zero capturing a lot. Whenever the turning is coming, you are just pressing that particular left and right, but zero position is more. So that is why if I show you my data, so zero captured a lot in this particular data. But if I give this particular data to my model will get biased to the zero only, because every time it will predict zero because it has seen zero data a lot. Almost more than 3000 data is like zero. Okay, so what I have to do, I have to remove some of them. So for this, what I can do, I can just take some of the sample. Let's say I only want to keep 400 example. Okay, 400 example. That means till this point, I'll be keeping the zero value. Okay, and everything I'll be removing. Now, let me just draw a line here. So for this, I have already written one code. So this is the basic of like your matplotlib code. If you understand matplotlib, you will be able to getting what I'm doing here. Okay, I'm just plotting this particular graph and all. Now, if I execute, now see guys, I have drawn this particular line. Now I'll be picking this particular example only 400 example I will be picking, and everything I'm going to remove. Okay, this is the idea. So that's how actually you have to perform some pre-processing step in your data, okay, before training the data in the model. So this pre-processing is very much required, otherwise you won't be getting good performance from the model. Okay, yeah. Now if you want to check like how much rows you are having in this particular data, you can also see that data.shape. So you are having 4053 rows and 7 columns. Why 4000 like rows? Because you can see center, left and right image is a separated, okay, separated one, like 3 column it is there. Now if you combine all the image, okay, you will see that particular number only. So if I show you, so plus 4053 plus 4053, we'll see that more than 12,000. Yeah, more than 12,000. That means my like image is correct here. Fine. Okay. Now, if you want to remove these are the zeros, so what you can do, I have already written one code for this. So this is the code. So it will automatically remove all the zeros from the data. Okay, as you can see, I'm just loading the starting angle, and based on the bins, actually, I'm just removing the zeros. Okay, and I'm only keeping 400 example there. Okay, so now let me execute. So it has been removed. So removed. See, this many like zeros has been removed, and remaining that many. Now what I can do, I can show you the plotting again. I can show you the plotting, the histogram again on the starting angle. Now see, my data looks good. Now it is perfectly in a bell curve. Okay, that means in a normal distribution. Now I can use it. Now there is no bias in this particular data, so my model can learn very easily here, right? Yeah. So these are some basics pre-processing step you have to perform. So I'm not going to like perform like more pre-processing step here, because next class actually I was thinking to show you like what are the pre-processing you have to perform and all, or else I think I can show you some more pre-processing, but just leave it. Okay, in the next class what I will show you, I will show you some more pre-processing step you can perform in this particular data. I'll also show you how we can perform the augmentation of the data. Okay, then after that, if everything is like let's say ready, then I will show you how we can train the model. We'll be creating this particular NVIDIA model. Okay, I think already given you the paper link. So paper link is there. So we'll be creating this particular NVIDIA model and we'll be training the data here. So this is the NVIDIA model we'll be developing. Okay, so let's leave this class till here only. So what you can do, I will share this particular code with you. So just try to practice. I just try to practice till here. Just try to download the data. Just try to perform these many pre-processing step and just be ready with the next class so that we can complete this particular pre-processing step. Then we'll be training the model, right? Okay. So now what I can do, I can share this particular link with you. I'm not going to download it because again, I'll be using the same notebook only. So let me share the link with you. That would be better. So here I'll just give the permission to all of you. So I'm sharing the link in the chat. Okay. So guys, now if you are having any kinds of query, you can ask me, or else I think I can conclude the session for today. Any query, guys? Uh, yeah, sorry guys. I think I disconnected somehow because of the internet issue. Okay, fine. So I think this is all from this particular session. So in the next class, actually, we'll try to complete this particular like pre-processing step. Then after that, we will start with the model training part. Yeah, so I'm getting some questions. So hi, will you deploy this particular project as well? See, you don't need to deploy this particular projects. We're deploying the projects in the simulator only. Okay, you don't need to deploy in the cloud platform because there is no use of cloud platform here. So on the simulator, I'm going to do the deployment in the autonomous mode. Actually, will be doing the deployment, and this is going to be complete end to end because I'll show you the drive function and all. Automatically, it will be working. You can check out my overview session yesterday already taken, right? Yeah. So thanks for joining, guys. With that, guys, thank you and take care, everyone. Bye.